Power rule is like an all-encompassing thing. We use it for every problem. Sometimes power rule is not enough. Sometimes we need to use the product rule like we did yesterday. And yet sometimes we need to use a quotient rule for division when we have division. So how do you do it? Well, here it is. So you take the derivative, or you take the low, whatever the low is, times the derivative of the high. That's one term. Minus the high times the derivative of the low. That's another term. Over low squared. Okay? High d low minus, or sorry, low d high minus high d low over low low. Yes, sir?
Isn't it on the board that's high high on the bottom?
Did I put high high? Yeah, you're right. It should be low low. Thank you. Yeah, this should be g of x. Okay. All right. So let's take a look. Let's do the first one. So the high is x function. The low is x squared plus 1.
But it's minus.
There we go, and there we go. Okay. All right, so let's find the derivative. So, okay. So the first thing is the derivative, sorry, the low times the derivative of the high. Well, the low is the green. So we're just going to rewrite the green. X squared plus 1 times the derivative of the high. Derivative of yellow is just 1. Minus. And then I always put the second part in parentheses and brackets because it's subtracting everything. Okay, so if there's multiple terms, it's going to be subtracting all of the terms. Okay, so now high times the derivative of the low over low squared. That's the calculus. Now the rest is just, like I said, most of the time you do these on tests, it's going to be multiple choice tests. So how far do you simplify until you get an answer you like? So we're going to have to simplify a little bit here. So here I would probably distribute the 1, and then here I would distribute the negative, and then multiply these two together. Okay, so let's see what happens when I do that. So I get x squared plus 1, and then I get minus 2x squared over x squared plus 1 squared. And then the first guy, x squared plus 1, I can write without parentheses because that one just has a 1 in front of the parentheses. X squared plus 1 squared. And then I can combine like terms. So I get negative x squared plus 1 over x squared plus 1 squared. Now, if that negative out here was a positive, you could simplify even further because I could cancel out one at the bottom because it's got 2. But because of that negative, they're not the same. They're very similar. The top and the bottom, this guy and this guy are very similar, but they're not exactly the same. So we're done. That's as far as you can simplify. Okay. Again, how far do you go until you find an answer you like? That one will probably match A, B, C, or D on multiple choice because most of these are going to be multiple choice. You'll find on multiple choice parts of the test. Okay? All right, so now let's do B. Again, low, high. Let's find the derivative. Low, D high, so rewrite the low, times the derivative of the high, which is 10x, minus high, D low. The derivative of the bottom is going to be 3x squared over low squared. Calculus is done. Okay. Last part, just simplify it. Clean it up a little bit, distribute where you need to, combine any like terms, get rid of the parentheses that you can. If you can't get rid of parentheses, it's okay, but try to go as far as you can. So here I would probably distribute the 10x, multiply these, and then distribute the negative. And see what's what. So I would get 10x to the fourth plus 10x, and then I would get minus 15x to the fourth over x cubed plus 1 squared. Combine anything you can. If you can, combine it. If you can't, don't combine it. Combine those two, we get negative 5 x to the fourth plus 10x over x cubed plus 1 squared. I think that's as far as you can go. The top has an x, you can factor out an x from the top, but there's really no point because you can't cancel out anything on the bottom. So that's as far as you can go. Wait, is that as far as I can go? Yes, that's as far as I can go. Because the top, I can factor out a negative 5x. So that would be x cubed. It would be x cubed minus 2. But that wouldn't cancel out from the bottom because it's an x cubed plus 1. So you can do it, but there's no point to it. Okay. All right. Let's see. Okay, so you got enough space. Let's do another practice problem. I'll let you guys do this one on your own. So we'll call this one C. Thank you. Okay, we'll call this one C. All right, here we go. Find the derivative. Same directions. Go until you match this. Okay. So we got to find the derivative. So low times the derivative of the high, which is negative 2x, minus high times the derivative of the low, which is negative 5, over low squared. Okay. Calculus is done. Did the rule. Now you just got to make it look like that guy over there. So over here, I'm going to distribute. And then over here, I'm going to distribute. So I'm going to get negative 12x plus 10x squared, because I distributed the first guy. And then I still have a subtraction, and I still have brackets. So then I'm going to distribute the negative 5, so I get negative 25 plus 5x squared. Okay, now I'm going to distribute the negative and combine like terms. Let me make this smaller. So I get negative 12x plus 10x squared, and then I'm going to get positive 25 minus 5x squared. Combine like terms. You get 5x squared minus 12x plus 25 over, that's as far as you need to go. That matches that. Okay. So again, it's kind of a repeating theme. The part that messes with students the most isn't the calculus part. They can do the quotient rule, the product rule, the power rule. They're good at the rules. It's simplifying it so that it matches one of my answers on my test. That's usually the case. So the better you are at that, the easier this will be. Okay? All right. All right, let's see. Oh yeah, we got plenty of time. Okay, so here we go.
Oh no.
Last 2 pages. It looks crazy, but it really isn't. The last 2 pages, the last sheet.
Oh my god, we have to find derivatives like different things, really.
So, higher order derivatives. Higher order derivatives mean when you go layers deep, right? So if we find one derivative, we go 1 layer deep. If we find second derivative, we're going 2 layers deep. Third derivative, fourth derivative, we can continue to go, you can go forever. So this looks harder than it really is. So let's say I have 10a. What derivative do you think they want me to find?
The fourth.
Fourth derivative. This is the original here. How do you think I'm going to find the fourth derivative? What do you think I got to do first? Do the first derivative, right? So let's do that. Let's do the first derivative. So we'll call this y prime. All right? I don't need any of my fancy rules, right? I don't need the product rule, quotient rule. I just need the power rule.
Oh, sick.
The good old power rule. All right? So what's the derivative of the first?
Minus 40 to the x to the 7.
Good. What's the derivative of the next term?
12x to the
12x to the 5th. What's the derivative of the next term? Good. And then the second to last term is just positive 32, right? And then the derivative of 1, negative 1 is 0. How do you think I'm going to use that to find the second derivative?
Do it again.
Do it again, yeah, do it again.
No.
It seems harder than it is.
That's what I thought.
Yeah, you just keep finding the derivative of the one you did before. You don't go back to the original, you go back to where you did before. So second derivative just means the first derivative of the first derivative.
Oh god.
So negative 280 x to the 6 plus 60 x to the 4th minus, what is that, 54
Oh
x.
god.
32 drops off, right?
What's a
Third derivative.
6?
What is 6 times negative?
1740.
280, what's 280 times 6?
1740.
1740?
I believe so.
I got 1680. Wait, is that what I did? Did I do something wrong?
12 plus,
Oh no,
plus
no.
4. Yeah, 12 plus 4 is 6, yeah.
1680. So negative 1680 x5
Yeah.
Yeah, I got it wrong.
plus 240
90.
x3 minus 54. So instead of doing 4 ticks, sometimes what they do is just put y4. That means 4 tick marks, fourth derivative. All right, so here we go. 5 times 1680,
5 times
8.
that is.
I got negative 8,400.
Oh yep.
And then 240 times 3
720.
720 squared, right? And then 54 drops off, and then you're done.
Nice. This,
So there is a reason why we do second derivative, third derivative, fourth derivative. There is a reason, there is a method behind the madness. Why do we need to do 4 derivatives deep? Well, they mean something. We'll talk about this next unit. But first derivative is slope, right? Slope of the tangent line. Change over time. What is slope of that? Think of your car. So if I'm going in my car, like if I drive, if I'm driving, and it says 35 miles an hour, that's my slope at this instant, right? That's my derivative at this instant. What would the derivative of that be? A word you probably heard before. So what is it called if I'm going 35 miles an hour, right? What is that called? What's a speed, right? Speed, 35 miles an hour. What's the derivative of speed?
miles per hour.
No, that's the units. What's the rate of speed? What is it called when you're picking up speed and slowing down? Acceleration. Yep, acceleration. Speed means I'm going 35 miles an hour in my car. If I'm staying at 35, am I picking up speed? No. Nope. So what's my acceleration? 0, right? If I'm slowing down, that's negative acceleration, right? That's what that is. So as you get on the highway, you got to pick up speed, right? You got to pick up speed to catch up with the other cars, right? Your acceleration picks up. So you have positive acceleration. That's why the gas pedal is sometimes called the accelerator, because you push it to accelerate to go faster, right? Just because I could be going 100 miles an hour down the highway, but if I stay 100 miles an hour, my acceleration's 0. I'm not changing speed, right? All right, so speed and acceleration are 2 different things. Okay, all right, here we go. So what I want you to do now is find the second derivative of this. Well, find the first derivative, and then I'll help you with the second derivative. Find the first derivative, and then I'll help you with the second derivative.
Oh, God. No way. I think that's it. Should be it. It's one big joke. This is one big joke, isn't it? Right.
Okay, so the first derivative is -1 over x minus 1 quantity squared. Okay. Now we got to find the second derivative. So that means I'm finding derivative of this guy. So that means I have to find d over dx for this guy.
Who's next? This guy.
Okay. Well, before we do that, let me see. Am I going to do that? Oh, I'll do it later. Okay. Okay. So low x minus 1 squared times the derivative of the high. Well, what is the derivative of the high? 0. That's the nice thing. When things are 0, what happens when I multiply by 0? Go away. That's nice. Always nice when things like that happen. Makes our life easier. Minus high times the derivative of the low. How do I find the derivative of the low?
Square first.
Yeah, so either expand it and use the product rule, or FOIL and use the power rule. Either one is okay, right? So how can I find the derivative of the second, of the bottom? You can use the product rule, because really this is just x minus 1 times x minus 1, right? You can FOIL that and then just use the regular old power rule. That's okay. Or you can just say, I'm going to use the product rule now. Whatever floats your boat. So if I'm using product rule, within the rule, because that's the thing, we'll have rules within rules. Okay? So if I'm finding derivative of this, because this was the bottom term, right? I go first times the derivative of the second. First times the derivative of the second, which is just 1, right? Plus
You could just multiply those.
second times the derivative of the first.
I think it's funnier.
Over the bottom squared. Well, the bottom's already squared. So if I square, how many powers do I have? 4. So the nice thing is, the first term completely went away. We don't have to worry about that because it's multiplying times 0. The not so nice part is I have a little bit of a complicated second term. So make it uncomplicated. Distribute. So I'm going to distribute here. And I'm going to distribute here. This is just times 1, so that's not going to change anything. Okay. So minus. When I distribute the negative 1, I'm getting negative 1x plus 1. This 1 here means multiply everything by 1. Well, does that really matter? If you multiply everything by 1, is it going to change? No. So just forget about that 1 there. And then the next one would be plus x minus 1. We distributed this 1, but it didn't change anything because it's just 1. Okay. Inside the brackets, I see things that'll cancel out. This guy, this guy. Right, I think I might have dropped a negative. Give me 1 second. The 4 changed to a 3. Oh, right here. Because I'm canceling out, I have the binomial here and the binomial here.
Oh, okay.
So I'm canceling out 1 power.
Oh, okay.
Yeah.
Yes, I tried writing x minus 1.
Okay.
Oh my lord, David. What should we cook?
Last one, letter C. Looks a lot harder than it is. Read it if you haven't already.
35y, d5y, derivative, a fifth
I just do
derivative.
one more derivative.
Yeah, just one more derivative. That's it.
2x.
It's not asking you to find the 5th derivative. You've already found 4 of them. Find 1 more derivative.
Alright, so
So how would I find 1 more derivative? So it's just asking you to find 1 more derivative of this guy. So how would I find derivative of that? This is a good review from yesterday. Power rule, yeah. I'm not going to use the quotient rule. I'm not going to use the product rule because there's no need to. How do I use the power rule? What do I got to do first? Before I even get to the power rule, what do I have to do?
Fix the square root.
Fix the square root. Yep. Fix it so that it's not a square root. 2x to the 1/2 power. That I can use the power rule with. I know what a power is. No more root. So, power rule, multiply, so move the original power times the original coefficient, and then we subtract a whole, right? You subtract a whole from the old power. So 1/2 times 2 is just 1, x to the negative 1/2, which is the same thing as 1 over the square root of x. And you are done. Okay. So those are the 3 rules we're going to use. We'll use them for the rest of the year. There's one more big rule that you're going to use that we'll talk about next week. It's called the chain rule. The chain rule is just as important as these rules, but I do them separately. So these are rules you're going to use almost throughout the rest of the semester, definitely. And even next semester when we're doing integration and derivatives are 2 sides of the same coin. So we still use a lot of these rules next semester as well, okay? So yeah, the better you can be with these the more comfortable, I should say, the more comfortable you are using these rules, the easier it's gonna be. That's why we practice. So tomorrow we'll do a practice. Tomorrow I'll give you a practice assignment, okay?